Okay, so here's the second part of the question number 3. So it says, what are the rules for order of operations? So please excuse my dear Aunt Sally. So you do parentheses first, exponents next, multiply and divide left to right, like you read a book, because these are equal. Now, neither is more important than the other. And then add and subtract left to right, same thing. Subtraction could come first, or adding just kind of depends on left to right. Again, parentheses is bigger than just parentheses. It's any type of grouping symbols. Like here, you would add before you square root a fraction bar. Here you would add and add before you divide. So those act as grouping symbols. So parentheses are kind of broad. Exponents, and then exponents are really square roots too. Like if you have this, that's the same as 9 to the half power. And then again, multiply and divide, add and subtract left to right. And then what is Pythagorean Theorem? So Pythagorean Theorem is a squared equals b squared equals c squared. It only works on right triangles. And c has to be the hypotenuse. A and b don't matter. And it's about areas. The area of a square on side A, the area of a square on side B has to equal the area of the square on side C. So usually your last step is to always square root because you want the length instead of, you usually don't want to know what c squared is. You want to know what c is. So, all right, go ahead and try number 4 and number 5, and I'll come right back. Okay, in number 4, I give you a formula and I give you some information. So the base is 2 feet. The height, which is always up and down at a right angle, is 6 inches. And so you want to find the area of the triangle, so half. Now the problem is, though, see how your units don't match. So your goal is to get like square feet or square inches. So I'm going to go ahead and multiply this guy by what? 12. So this would be what? 24 inches. And I'm going to use the formula with that. So the base is 24 inches. The height is 6 inches. So if you multiply across, you get 72, and it should be square inches. Or you could write it like that. If you wanted to, you could do feet. So you could have, and again, you might have a right triangle that looks like this instead. You could do 2 feet, and then 6 inches is half a foot. So let's see what happens if you do that. You get half base times height. Your base is 2, your height is a half. So let's see, a half times 2 is what, 1. So you get a half of a square foot would be your final answer, okay? So either way, you just have to have consistent units. All right, number 5 says to multiply fractions, you do not need a common denominator. And see if I can scroll down here at all. And the answer, so I'm sorry, I'm filling in the blank here. So to multiply fractions, you do not need a common denominator. And that is because when you multiply, you're creating something new. So you just go straight across, you get an 1/8. Because if you have a 4th to begin with, and then you decide to take half of that 4th, see how you have new units of 8. All right, so you're creating something new. That's why when you multiply exponents, they change because you're creating something new, x to the 5th. And then with fractions, when you add fractions, you do need a common denominator because it's kind of like you're collecting like terms. So if you have a half and an 1/8, you would need to get a common denominator of 8 here. So get the same unit, so that you can add like terms. So cats and cats make more cats. So I have 5 8. So that's like a unit. So that's why when you have something like, 2x to the 3rd plus 5x to the 3rd, you're just collecting like terms. So you get 7x to the 3rds. Kind of like here, you have 4 8s, 1 8, you have 5 8s. But you can't add them when they're different because they're not like terms. All right, pause and try number 6, A through D. All right, so first of all, we have to plot. And I give you some graph paper there, but let's see, what's -2, 5? So you always go back and forth first. Think of historically, people would have walked back and forth first and then gone up and down. So -2, 5 is right there. And then the other point is 2, -1. So you'd ride back and forth and then go over 2, down 1, okay? And so there's your points, all right? And if I draw this line between them, I want to find the slope. Now, you could count. I know this has negative slope here because, obviously it's going down here, right? But I could count. So if I rise 1, 2, 3 and run back, what, -2? So if I go up 3 and back 2, go up 3 and back 2, that actually works. So I'm going up 3 and back 2, which is negative. So -3/2 is my slope. The other way I could do that is to make the little chart, input-output chart. So this is going down by 6. This is going up by 4. So change in y over change in x is -6/4. And I could simplify, and what is it, -3/2, get the same answer. And if you like the formula y2 minus y1 over, it doesn't like to write over here, x2 minus x1, same thing, you should get a -3/2. Okay, so then it says find the slope of the line. Okay, what is the y-intercept? Well, I can actually see it here. It's actually at 2 because it crosses there. If it doesn't cross nice, like say it crosses at a fraction or something like that, and you're like, okay, how do I get it if it's not nice? That's when you sub 3 out of 4 into y equals mx plus b. So anything that's linear has that formula. What do you know? Well, you know the slope, so you know this guy. You know an input, you know an output. So the only thing you don't know is b, and so you can solve for b. So let's sub in what we know. I'm just going to sub in, I don't know, what do we have? One of the points is what, -2,5. I'm going to sub that in. So input, output, or x and y. So my output is 5 when my input is -2. My slope is my rate, -3/2. And you can do -1.5 if you like decimals better, not going to hurt. So there's my b. So 5 equals, and again, if you're not comfortable doing this without a calculator, you can do it with one. You're going to end up with a +3. And then to solve for b, to get rid of adding, we need to subtract. Or you could probably just look at it and tell that b is going to end up being 2. All right, so the y-intercept, or the starting amount, is 2, and I can either get it with algebra or, in this case, looking at the graph. And so then it says, what is the equation of the line? So y equals, and then you're going to fill in the blanks, basically, here. So what's my slope? So we said the slope was, what, -3/2. Right, and again, -1.5 is okay. And then my b is +2. So a general equation always has to have an x so that you have a place to put input, and it always has to have a y so you have a place to put output. But there should be a rate, a number rate, and a number starting amount. Cool thing about this is you can actually check your answers. So we had those 2 points, -2, 5. So shove a -2 in here. So take -3/2 times -2 plus 2, enter on a calculator. If you don't get 5, you're wrong. And then what was our other point? This one, we had another point. What was it? 2, -1. Same thing. Shove in your input into the formula. So -3/2. Shove in 2 plus 2. Enter. And again, if it doesn't give you an output of a -1, you're wrong. But in this case, they both worked, so I'm good. All right, go ahead and try 7 and 8. All right, so let's look at 7 here. What do I have? I have the points -3, 4, and what, 0, -5, and it says find the distance between the 2 points. I like to make my input output just like I'm doing slope. This is going down by 9, this is going, what, up by 3. So if I wanted my slope, I do change in y over change in x and get -9/3, and my slope would be -3. But I don't want slope, so I don't want to reduce it. I want the actual distances. So these are my original distances. And so if I do Pythagorean Theorem, I'm going to ignore the negative. Actually, I'm not going to square root right away. That's if you want to do the distance formula. So I'm going to go ahead and square these. So you can just leave off the negatives, because in real life, in trig, you have negative stuff, but even if you square it, a negative times a negative, like if you accidentally do this, when you square it, you still get positive. So we're not worried about any negative distances. So we're just going to do Pythagorean Theorem with the original, not the reduced, because that would be a baby triangle. Go ahead and add these. You get this 90. But again, remember, Pythagorean Theorem is all about area, so we need to square it to get it about distances. Excuse me. So it'd be about 9.49 units. And again, if you need to graph this to see it, you certainly can do that. So if you would rather just graph it on graph paper, not a big deal. Make your XY axis. 0, -5 would be down on the y-axis because the number's in the y spot, and -3 4 would be here. So again, you could just draw in your right triangle and then get your 3 and your 9 off the graph. That's the fifth one. And then do Pythagorean Theorem that way. So it's kind of up to you. All right, let's go ahead and look at 8 and let's see what else do we have. 8 and 9 here, scientific notation. So remember with scientific notation, the first number has to be between 1 and 9 point something and times 10 to some power because it's multiplying by 10 that's going to move the decimal. So the first one, 5.93, oh, my pen's acting up again, times 10 to the 8th. All right, I'm going to try to get that to work again. Sorry about that. Having issues today. So, oh, maybe 10, there we go. 10 to the 8th. So, I mean, this is a positive exponent. This is going to be a huge number. What you're doing here is you're multiplying by 10 times 10 times 10, 8 times. So that's going to move the decimal, what, 8 jumps. So 1 jump, 2 jumps. 1 jump, 2 jumps, 3, 4, 5, 6, 7, 8. So, what is that? 593 with 1, 2, 3, 4, 5, 6 zeros. So 593 million. All right, the next one is 5.93 times 10 to the negative third. Okay, negatives mean reciprocal. These are tiny numbers. Technically, what this really means is you have 10 to the third in the denominator. Negative exponents mean to reciprocate. So you're really taking 5.93, divided by 10, divided by 10, divided by 10, 3 times. That's why negative exponents give you tiny things. So if I have 5.93 and I move the decimal 1 jump, 2 jumps, 3 jumps, because when you divide by 10, you can just move the decimal, my final answer is that guy right there. All right, I'm going to go ahead and get a clean screen. So do the last two if you haven't already, and we'll double check those. Okay, so here we're putting them in scientific notation. So again, remember there has to be 2 parts, a decimal part and then a times 10 to some part. If you don't have both parts, you're not right. So take all the significant digits, and if there's zeros trapped in between there, they count. So you always put it after the first place over here because you want this to be between 1 and 9 point something. Times 10, because the 10 is what moves the decimal. Now, how many jumps does it have to go? Well, right now it's here. So 1 jump, 2, 3, 4 jumps. And is it a positive or negative? Well, this is a tiny number, so this has to be a negative exponent. To check your answer, you would take 3.089, the decimal. And negative exponents mean you really have 10 to the 4th down here. So on your calculator, take 3.089 and divide by 10 4 times. And again, my pen is just acting up today. So if you divide it, if I can, maybe write it, 1, 2, 3, 4 times, if it doesn't equal your original number, you're wrong, because these have to be equal mathematically. So you should be able to check your answer. All right, let's see if we can get the pen to work again. So this one, take your significant digits. So I have 9, 0, 8, and again, you always put your decimal right here so that this is between 1 and 9 point something times. The 10 is what moves the decimal. If you forget that, like 9 to the 2nd power is 81. It's not going to equal the same thing. So you need times 10. Decimal always starts at the end of the number if it's not there. So 1 jump, 2, 3, 4, 5 jumps. And it's a positive exponent because that's a big number. And again, on your calculator, you can check. Multiply by 10, 10, 10, 10, 10, 5 times, and it should be this big number. If it's not, you are wrong. Because again, this answer here, when you multiply it out, has to equal that. And this answer here, when you multiply it out, has to equal that. It's just a shortcut of writing it. You're not rounding the number. You are leaving it exactly the way it is. All right, go ahead and try number 9. And we'll actually go ahead and try it, but I'll put this on the next video.